AlphaGo Zero and Tesla self-drive. I see the combination of what AlphaGo Zero did, what David Silver, the head researcher there, did, and what Tesla is trying to do. I think the next big step for Tesla is to find a way to incorporate AlphaGo Zero technology into their full self-drive. I want to discuss this, and I think this is one of the most important episodes since this podcast has been launched a year and a half ago, because I think I'm laying the groundwork here for what I think the story of Tesla will be for the next couple of years, and this is our largest position. So our wealth generation depends on the success of this project, and hopefully I'm right about this. This is the Not Even Wrong podcast. It's August 25th, 2021. This is Krim Delco. Since the last update, we're up 6%. The market's up 50 basis points. We're up 9.3% for the year. The market's up 19.3%. We're underperforming by 10%. Tesla's AI Day was last week, and they presented a lot of things. We discussed it. A lot of things were discussed. I've actually missed out on the most important thing. The most important thing on this AI Day was a section presented by a gentleman called Ashok, who is the head of AI Autopilot software at Tesla. So he does what's called control and planning for the car. So think of it like you have Andrej Karpathy, who takes care of creating a model, understanding, okay, what is around us, and now somebody else has to take all of that and actually tell the car what to do. This is control and planning, and I believe that this part of the presentation was, on the one hand, weak, because they didn't really go into enough depth, but it also opened the door for what I think is the big future of Tesla. And the big future of Tesla is to solve the control and planning problem through AlphaGo Zero type technology, which is some sort of self-play, reinforcement learning based learning, where the machine learns by itself on its own to achieve the ultimate goals. And Ashok talked about this. The ultimate goal is to get from A to B in a comfortable and safe way without injuring anybody in the car or outside of the car. So I think we have to, of course, always in AI, we have to create some sort of ultimate purpose or a function that needs to be optimized. How we get there, in fact, can be left to the machine, That's what AlphaGo Zero did. Let me explain a little bit what AlphaGo Zero did, and then let me make the arch from AlphaGo Zero to Tesla, because I really think that this is the future of Tesla, or some sort of AlphaGo Zero type approach. So AlphaGo Zero is born out of the DeepMind project that is now part of Google. David Silver is the head researcher there, and I've read a lot about him, heard interviews with him. So this is my knowledge about it. It's all from I've never met him, so I don't want to go that far, but I think I understand sort of the gist. What David says is that the DeepMind team has created a system that is able to beat the best players in Go, which is a board game in Asia, a very complicated board game. And what they did first is they taught a system by watching other players play. They also taught the system how to play based on some sort of search-based algorithm where you have certain strategies that are known and then you search for the best one. So no matter what, through focusing on watching other players and also having some sort of, let's call it hard-coded search mechanism, which is that once you're given certain strategies, now you have to find the most optimal one, that kind of thing. Given all of that, Go was able to beat the best players. So Go as a project was already a success before AlphaGo Zero. What AlphaGo Zero did, and this is sort of really the big breakthrough in my view, is David says that we thought about taking away all that knowledge that we actually put into the system and let the system learn by self-play. By taking away knowledge, you generalize the solution, okay? By taking away knowledge, you're not narrowing down the solution with your own biases, and you're letting the system develop, a general solution to this particular problem. But you see, the arch is here, is visible, that you can, of course, if you can learn through self-play how to beat the best players at Go, maybe you can learn to self-play also how to solve other problems. And David makes a huge statement in one of the presentations he gave. I think actually I think it's the Lex Friedman podcast where he did that. He said that I predict that the system that we had, let's say in 2019, with whatever algorithm we did, if we 5 years later run the same algorithm with Moore's law, more compute power, that system will be better, and so on and so forth. So he's basically making the prediction that once you have the algorithm and the self-play is sort of structured in a reinforcement type learning concept, then it's all about compute power. And the more compute power you have, the better you get at playing the game. Let's let that sink in for a second. So what David Silver is saying is that it's not about the knowledge, the experience, none of that stuff. Anything that we humans understand about the game of Go is irrelevant. All we need to do is find an intelligent way to play a reinforcement learning game. In other words, a game where you get better by being rewarded for doing the right thing, and that's it. It's a general solution to the problem of Go. This is a huge thing. This is because now we can sort of do transfer learning here. If we have a general solution to solve the self-drive problem, then we have a general solution to solve any kind of problem. Now, of course, how do we get from AlphaGo Zero to self-drive? This is the big question, and this is why I think the AI day was, on the one hand, a little bit of a disappointment. On the other day, it opened up a big window for us. The same day, on the first AI day, actually, was us. Back then, we were invited, fortunately, so we were able to ask questions. And I was able to ask the question, well, what's up with LiDAR? And the answer was, well, LiDAR is a crutch. And that was the beginning of the end of LiDAR for Tesla, or maybe not the beginning of the end, but it was definitely clear that Tesla is going all vision and nothing else, and that is going to be the future for Tesla. And from there, we went to the vector-based model of the reality and all these things that Andrej Karpathy explained. And that's great. I think this AI day is the beginning of the end of the sort of search-based planning optimization solution that Tesla is applying. Because what they're doing now, according to Ashok is the head of, I think it's called head of autopilot software at Tesla. So he is in charge of planning and control for the system. So again, if you have a model of the world, now you have to somehow tell the car what to do. That's what Ashok runs. And he was talking about search-based models that sort of look at the best possible solution in any given moment. And there's, I don't know, thousands of millions of searches that are done per second. I'm not quite sure, but something along those lines. And then they're using some sort of Monte Carlo analysis to find the best optimal way from A to B. Whatever he explained to me it sounded a little bit cumbersome. It sounded not learning based. And this is a quote now from Ilya Sutskever or something like that. I might be butchering his name. He's the gentleman that co-wrote the ImageNet paper in 2012 that sort of broke broke loose the whole AI revolution together with Jeff Hinton. And he said something on another podcast, I think on the Peter Abil podcast, where he said that when he was a student, he was looking for where the most learning happened, the most machine learning was happening. And I think it's a nice quote to summarize. I think what's really important is that any kind of solution within the whole realm of computation and the whole realm of AI, which is just a narrower version of computation, any kind of, like, anybody who's working on any kind of problem that has to do with machine intelligence, I think should always be looking for where is the most learning happening. Or where do we have the least human input, human coding, expert system? Now, we do have human input, of course. Somebody has to build those reinforcement learning algorithms and all that stuff. Humans are very important, but not for the object matter, not for the, subject matter. So this is exactly the opposite of, let's say, how our workforce works. We always look for people with experience. Okay? Whenever we hire people, we want people with experience. Why? Because we need subject knowledge, domain knowledge. I think the future of AI is the exact opposite. We don't want domain knowledge. We want general knowledge how to solve problems. We want a system that can, through self-play, learn how to solve problems. Now, why is this good? Because self-play, according to David Silver, now I'm back to AlphaGo Zero. Why did AlphaGo Zero succeed? Because in reality, what AlphaGo Zero was able to do is just discover new ways of solving problems. And I am sure on the path from starting from scratch towards winning against the best Go players, probably AlphaGo Zero did a lot of stupid things. In fact, many stupid, millions and millions of stupid things. That's why David says the more compute power we have, the faster we can solve the problem and the better we can actually get, because we can get more and more potential solutions. Now, there is, I think, 10 to the 120 possible states in AlphaGo. That means that there is so much more ground to be covered in terms of what kind of positions there are possible, that David thinks that the more compute power we have, the better we can get for a long time. Now let's get back to self-driving. I think it's a very similar problem. We have 10 to the many powers of potential states of driving, particularly city driving. City driving in California, city driving in India, all these possible situations, pedestrians, weather, all that stuff. And within that context, if we can find a way through self-play to learn how to drive, it will be much better. Again, we need all the stuff that Andrew Karpathy is doing, because we need to have a model of the world. What we don't have right now is a good way to use that model and make predictions of what to do next. And this is where the self-play mechanism comes in. So what are we doing right now? I contacted Peter Abil. I said, listen, I think you should talk to somebody on your podcast, the Robot Mind podcast, because I think this is the best platform for this. Talk to somebody. In fact, talk to Elon Musk about this. I think Elon Musk needs to go out there, and I think the Peter Abil podcast would be the best. Lex Fridman will also be good, but I think Peter Abil is even better, because Peter Abil is focused on researchers. He's an academic, and he will, I'm sure, get enough traction also for Musk to hire the right people. Because what's going on here, let's say if I take Ashok, now Ashok has been with Tesla for 8+ years. He's a Carnegie Mellon guy, and as good as he is, I think he is still embedded in the DARPA challenge methodology of doing AI, which is combine all these things, sensor fusion, and then put all these things together. Now he's at Tesla, so he's gotten rid of the sensor fusion part of things, but I feel like he's still kind of, for lack of a better word, an old school type AI guy who uses domain knowledge, combines it with some sort of learning, and then tries to sort of step slowly towards a solution. I think the solution here has to be that we take away all the knowledge. Basically, the car should not know anything about driving, and then through self-play, learn how to drive. Now, can this be done in the real world? Probably not, because we would be killing people left and right until we figure out how to not kill them. So clearly that's not going to happen. So I guess the solution has to be actually somehow in a simulated world. Now, Musk said that simulated worlds don't work. There's no such thing as a simulated world. So I think the problem is a little bit deeper than I'm painting it here. But I don't know if the solution can be self-play, because driving in the real world is not like playing Go. For sure. But it has to go down that route. And we have to find ways to incorporate. Here's basically how I think the AI Day #3 in maybe 2 years should be. It should be that we have to find a way where the only bottleneck is computation. It shouldn't be that the bottleneck is things like labeling, auto-labeling, all that stuff. That should all be gone by now. And the only bottleneck should be computation. If we could get there, then we will crack self-driving the same way AlphaGo Zero has cracked the game of Go. This is my prediction. If Elon Musk can walk on stage on AI Day 3 or 4 or 5, whenever that may be, and say, the only thing left to solve is computation, because we've solved the problem of how to intelligently write a reinforcement learning algorithm, or maybe some other algorithm, maybe even a GAN network or something like that, whatever it may be, whatever the AI method is. And I think reinforcement learning probably at this point seems one way to go, because again, AlphaGo Zero has succeeded with that. So meaning you reward the car if it does something well, and you punish the car if it does something wrong, and you just keep going until the car finally gets to the end point, the solution, which is get me from A to B safe and as fast as possible, and safe for everybody else. So if computation is the only bottleneck, then full self-driving will be solved. Then maybe it can't be solved because we don't have enough computation, but Moore's law will get us there. So where does this leave us now? On the one hand, very optimistic, because I think we have a path now. On the other hand, we don't know if Tesla can do it, because first and foremost, they're not doing it yet. I believe that Elon Musk will jump on this bandwagon. I hope that Peter Abil will get in touch with him and do this interview with him, because this is the key. Elon Musk, this has to come from the top. This is one of those big decisions, like I spoke in one of the previous podcasts. Whenever big decisions are made, when Jeff Bezos decided that Amazon has to be built on a distributed computing platform, and everything has to be cloud native written software, because that was the basis for AWS and the birth of the modern cloud. That was a big deal, and it required a lot of rewriting of software and all kinds of stuff. When Tesla made the decision to go camera only, that was a big deal, because it required a lot of rewriting of software. This is another one of those big deals. In fact, this is a gigantic step. It's a gigantic step towards a future where self-play, self-supervised reinforcement learning is the basis for any kind of solution to general intelligence. To any kind of intelligent solutions to a general problem. It can be self-driving, it can be other things also in the future, translation and so on and so forth. The key is that the machine learns by itself. The machine figures it out by itself, because that way it's the most general, it's not human biased, and therefore we have a much better chance to solve it. And all we have to do is just get it more and more compute power, which is also one of the theses that we have at Orange Capital Partners, which is that in the end, wealth is generated by those companies that can apply as much as compute power as possible to real world, in particular physics type real world problems. Thank you.